Alright, welcome back. I think today there's a couple things. So yesterday we were trying to fix our diagonal movement, and I tried it on my my laptop, and it turns out it wasn't messing up on my laptop. So I'm thinking that this was just, it's laggy because of all the things I'm doing, because I'm streaming and recording and you know, OBS streaming and then live programming music and this graphics in the background and running the game. So it's just a lot for my computer. So I'm not too worried about it. There is a couple of things. I noticed that in the original Link's Awakening, and you know what? I think I'm gonna go ahead and make that keylogger I was talking about. So let's get going on that. Let's just do a quick, and actually I don't know what size I want the keylogger, so let's see if we can figure out what size we want a keylogger to be. So we'll go down here. Let's see if we draw at our screen height limit minus 16 and then a y of our virtual width minus 16 times 3, and the 16 is just to see if a 16 size square is way too big. We're not seeing it because let's just draw it at 0, 0 with a width and height of 16. Let's just see the size. Okay, that's probably a bit too big, so let's go for 8. Let's see if we go 8 by 8, if that's big enough. So this is going to be for each key. You know, up gets one little square, left gets one, right gets one. Yeah, because we don't want it to take up too much screen real estate, so let's go for a size of 8. And we can scale it if we need to, but so we're going to go 8 by 8 here. Now let's give us, we're just kind of mimicking a key we can press. So we'll just have all the arrows. Actually, we'll just do one and then copy and paste. So we want like a light gray background. It's already a light gray background, but you know what? Let's do white for when it's not pressed and then gray when it is pressed. So this will be our up being pressed. Does that read as an up arrow? Yeah. And then we'll just use that same arrow for all of our sprites. It's just something simple like that. So we want to export as a PNG. And we want to put it, yeah, here. This will be arrow up. Actually, just arrow key. And then we'll save a darker one as well, and that'll be like it's pressed, so that we can tell when it's pressed. So we'll export this, and this will be arrow key pressed. Okay, and then let's get these imported. So we got to go to our main and we got to import it as a drawable, so Lua knows it can draw it. So right here, we'll say arrow keylog, or keylogger. Arrow keylogger gets love.graphics, new image, and it is source pics, and it was arrow key.png. It was arrow key and arrow key pressed. Is that correct? Keylogger pressed. I guess I want to do camel case here. Okay. So arrow key pressed and arrow key. So now let's just try to draw these arrow keylogger and arrow keylogger pressed. So we'll go. For now, we'll just go into our play state. Actually, it shouldn't be in our play state. It should probably just be in our, or not our player class. It should probably just be in our play state. So let's do this. We'll say love.graphics dot love.graphics dot draw, and what we want to draw is our arrow keylogger. And where we want to draw it is at, for now, let's just get it on screen. So we'll see if that gets us our arrow key press PNG does not exist. So what did we save it as? We saved it as arrow key pressed, not camel case. So we'll just rename it to be camel case. So we don't crash, and maybe we'll be good. Okay, so what we're doing is rendering a square right over where we just drew it, so that's why we didn't see it. So we turn that off, and we still got it. We need to set our color. So in our play state, we'll go ahead and just set our color here to be white so we get a full normal picture of it. So it is set color. And you know what? Let's go into our constants real quick and just give us a white. Actually, we've got a white. So all we have to do is say set color white, and then we should be able to see it. Okay, there's our up arrow. So let's get... we want to draw another one 8 pixels over just to see. Let's just see, we've got 2. Okay, that's good. But we need to rotate it. So I think it's X, Y, and then rotation. Let's just see if we put 90 there, if it'll rotate it. Okay, it does, but we need the offset. So maybe we'll put the 8 as the offset. That is not it. We need to go look in the documentation real quick. So it is a love.graphics.draw. And we just need to see what the arguments are. It's an X, a Y, and a rotation. But then it's scale factor, origin offset. So scale factor 1, 1. Okay. So this is in radians, which I am not remembering. Those are doing. But if it's radians, let's just say positive scale factor, and then an X offset of 8. That's really jacked up. So radians 2 degrees is what? 1 radian is So if we want 90 degrees, 1.57 radians, there's got to be a better. To change from radians to degrees, you need to multiply the number of radians by 180 over pi. There's got to be a Lua way to just do degrees, right? Love 2D degrees. Radians to degrees. So what we can do is just say we would want to convert our degrees into radians and then save it. So math.rad should save it as radians. So what we can do is up here in our init, we can say 90 degrees. Can I do? I don't think I can do a number as a variable, but let's see, 90 degrees. We'll do camel case, so 90 degrees gets, and then we do a math.radian, and we give it the 90, and then we should be able to draw this at 90 degrees just by saying 90 degrees. That's not looking right. I'm no expert, but that's not looking right. Let's not give it an X offset and just see where it puts it. And we'll turn off this first one. Okay, what the flip? Let's just draw this way over so we can see what the heck's happening. Oh, you know what? The rotation, we messed this up. This should be 90 degrees. So it's XY, scale factor. You know what? I gotta look it up again because I already forgot. It's a drawable XY rotation, scale factor XY. So XY rotation, scale factor, scale factor. So drawable XY rotation, and then scale factor, scale factor. So this should not scale it, but should rotate it 90 degrees. And it does. So let's I guess we got to make our other ones. We got to make a 180 degrees, and we can actually instead of calling it I guess we do want to call it what it is. We want to call it what it is. I was thinking we could just save it as right, because it's the right arrow, but we kind of want to be descriptive. And then we want a 270. And then we will... You know what? I'm just going to render them all next to each other and see that they're just working correctly and that we can identify them. If we want it to be right next to each other, we give it 8. We could stay at a y of 0. And then we need to draw our next one, which is going to be at 16 on the x, and it's going to be 180 degrees. And then our next one is going to be 24 and 270 degrees. And then we're not drawing them. What's going on? Oh, what? We're drawing them all in the same spot. X and Y. Why would they be right there? Let's just say that that's 80. Do they both show up? Okay. So why does... They're 8 long, so why does that work? Okay, this is strange. X and Y. Why is this happening? Let's just say we're trying to draw this second one. Okay, that looks right. Then we're drawing the third one. And that one's not appearing. 180 degrees. What is 180 degrees in radians? I guess we can just scale factor it instead. I never learned radians, so I don't really know. 180 degrees radians. It's just pi. Okay. But let's draw it at 32. Actually, let's draw it at... I guess let's just draw it at 32, and we'll say we want to flip the 90 degrees on the X factor. I don't know why the 180 wasn't working, but if that's that one, then a -1 should flip it so it's facing left. And it's not, because we don't have the X offset. Okay. I'm a little confused. Arrow keylogger. What are we doing different? Arrow keylogger. Let's draw it at 32. We're drawing it at the 180 degrees. And we're not seeing it. Degrees. Why? If we draw it with no rotation, we're fine. But if we draw it at 180 degrees, we just don't see it. Why? It might be rotating. It does look like it's rotating. So I think we need to pass the X offset here. I think this is why we had to put in 8, or we had to put in 16 because it wasn't doing this X offset. So I think if we just do this, pass in the same X offset, this would hopefully be right next to one another. And then this could be 0 still. This would be 16. And then we need to offset this with a -16, I think. Just like this one should be a -8. Okay. Not quite. We need... If we do a positive there... This is a little strange to me. Maybe 0 on the X. I guess I'm just not understanding how it's rotating the image. So let's give ourselves a variable called rotate. It's going to start at 0, and it's actually going to start, since it's in radians, we need, let's just start at 0, and we'll increment it. Rotate gets itself plus, let's say 0.5, and we'll just draw one of these guys, and we'll draw it in the middle of the screen-ish. Let's just say 100 and 100, and then we give it a... None of my keys are working. I don't know why that happened. Okay. Let's say 100 and 100. And then our rotate is actually our value rotate. And then we'll see what that looks like. Okay. So it looks like it rotates it around the top left point. This almost looks like a butterfly. It looks like it rotates it around the top left. So if it's 8 by 8, oh, and you know what? Yeah, if it's 8 by 8, then what happens if we give it an 8 and an 8 on the offset? That's the scale. That's the scale. So we want to say 1 and 1 for the scale, and then we want to say 8 and 8 and see what that looks like. Still at the top of the top left origin point. Okay, so we want to rotate it around. We want to rotate it around its middle. So does that mean half the size of the sprite? It's still not offsetting. So let's just see. It defaults to 0. So let's just see what 1 and 1 looks like. Okay. And then 4 and 4. I'm looking for it to spin perfectly in the middle. Okay, there. So it's a positive number, and it's half of its width to rotate it perfectly in place. So what we can do is, now that we know that, we can say, okay, we're going to render that guy at 0, 0. We're going to render this guy at 8, 0, which should be right next to it. And then we want to always be giving our origin offset to be this. Okay, yep, we need to draw this not at rotate, but 0. And why is this looking like that? Dude, what is going on? So it's an X and Y, a rotate, a scale, and then an X offset, which we don't need the X offset for when we're not rotating it. So that draws it normal. And then the second one we're drawing is 90 degrees. I don't get why this is commented out. I mean, it's not commented out, but it's treating it as such. Let's just... We're trying to draw it directly next to it. So we give it that 8. 0 on the Y, 0 on the rotate. Actually, we want 90 degrees rotate. So 90 degrees. I don't know where my autocomplete went. And then let me just detach and reattach and see if that fixes some things. Okay. Dude, I don't know where our autocomplete went, but 1 and 1 on the scale, and then a 4 and a 4 on the offset. And it's still jacked up. So we're rotating it around the middle, so that would mean why we should be drawing it at 0. So why would that be so high up? That's jacked up. I don't get what is going on there. Okay. Was that it? That was the right arrow? So if we turn that off, we should just see an up arrow. We do. And then when we draw this one, we see the right arrow. But we're trying to scoot it to the right. It's not supposed to be flush with the left. That's what this X is for. So why is an X of 8 drawing it at 0? I don't know why. But 16 is drawing it right there, so let's just move on with that. Okay, now we've got, let's put 32 and keep the pattern going. I don't know why. And this is messed up. So where is this guy? That's the right one, but it's just so far down. Why would a +5 draw it above off screen? So like, let's put it at 0 and let's give us this X offset of half of our width, which should be 4, and the Y of, it's still jacked up. Why is it so high up? So, okay, why is it shifted up though? Okay, so I guess I'm not understanding what the X offsets are doing. So if we put this at 16, why would that draw it right next to this? I have no idea. Why would the same X position? Maybe we give this a 4 and a 4. That's jacked. That's jacked up. I think it's because if we think about it in radians, or like if it's rotating on this point, 90 degrees would make it need to be offset on the X only and 4 on the X. But if it rotates 180, it needs to be offset both positively on the X and negatively on the Y. But why is it like that? Like why is that how they do it? So I want to figure out how to get this to be 8 and the right amount of X offset. So I think if we rotate it 90 degrees, then we need to X offset by a +4 and a 0 on the Y. That's not quite it. That's not it. I really thought I would be able to whip this out. Okay, So let's offset it by 8. Okay. Then let's offset the y by 8. Man, I really don't get it. I really don't get it. I guess let's go back. Let's go back to rendering at a rotate angle so that we can debug a bit more. And we'll put it just at like 2020. And then, okay. So it's rotating, and let's... I'm really confused. Let's do this as 0.1. Actually, let's do 0.05. So we can just see what's happening. So it's rotating it on the top left point. So an x offset of, if we give an x offset and a y offset of half of our width, meaning 4, then we should see it spin in place, and that was the scale. So we need a 1 and a 1, and then we need a +4 and a +4. So now it's spinning in place. So what does that mean for our x position? Does that mean we're drawing it at the same 2020? Because if we put it at 0, it'll spin off screen. Okay, so what we want to do to our x is give it half of its width and half of its... we want to give this x offset. See, that doesn't make sense to me. So why would we have to do... I guess since it defaults to rotating at origin point 0, 0, we have to just modify the x and x offset the x. But does that mean we can have just a variable, a constant? Because if we want this, like let's say we want it 1 pixel worth over, can we say, and actually it's 8, so we can say +8. Dude. 8 +8. So will this be the next one over? No, it isn't. Why? Oh, we don't wanna increase our y, we just wanna do our x. Okay. So that is right. So if those are all 4, then let's go ahead, let's make a constant called and we want something. It's just 4. It's just a constant of 4. I would just call it rotate offset. And we're going to set it to 4. And then we can replace all of these 4s. So we can go substitute our 4 with this rotate offset. Okay. So now we're still getting that. And then this would be 4 if we want it at 0, we don't do anything. Yes. And then if we want it at, let's do the rest. So we've got, that would be 1 key. Then we want to offset it by a whole 8 to be to the right of it. And then our actual rotate, we don't want rotate, we want this 90 degrees. So is this going to be our right arrow? Yes. So we can do, that's our right, and then I guess let's hope that this is our, another 8 pixels to the right. We want our 180 degrees. Let's see if that's okay. Perfect. Then we want our 270 degrees. So we give ourselves 24, and then we give ourselves 270 degrees. Perfect. So now we've got our 4 keyloggers. Okay. So we'll do this at a rotate of 0. So now we've got our 4 arrow keys for our keyloggers. So now we just need to get these placed in the bottom right. And we'll do it. So let's start with our right key, which is the second one we do. So the second one we do, this is our right key. So let's say that this is right. So we'll go add a comment saying right, and we want the Y position to be the screen height limit minus 8 for how tall we are, and we want the X to keep the rotate offset, but we want to be virtual width minus 8. So we want it right at the bottom right above our HUD. That's close. That's close, but that's not what I wanted. Minus 8. It's a little too high, so this is wrong. But why would 4... Okay, I don't know why 4 makes it right, but it's right. So there we go, there's right. Now let's do our down, which is our third one. Should be the 16 here. So this should be down key. So if we go here and we go, this is down, then we can say something similar, but we want the virtual width minus 16, because we want it to be left of our right key. And then the Y, we want to be screen height limit minus 4. I don't get why it's minus 4, but we've got it down there. So now let's do our left key, and that would be this one. So let's go call this one left, and then we will we'll go to this. Dude, what is happening? Okay. We want to go virtual width minus 32, and then our Y, we want to be a screen height limit minus 4, and we're drawing it at 270 degrees. That's not quite right. We want the X to be 24. Yes. Okay, so there's our left, down, and right. Now that's looking good. Now let's just put our up arrow right in the top. So it's the same as the down on the X. So we'll go here, we'll say up, and we'll go, I know we want to go in X of the same, so it's going to be virtual width -16, same as the down, but then our Y would need to be screen height limit -4, -8, so -12, I guess. And we missed something in virtual. We missed a plus here. Perfect. Sweet. And we can actually do 1 pixel. Yo, aka Bob, what's going on? Look at the keylogger action we got. It only took me 41 minutes to get this on screen. Okay. We can draw the Y 1 pixel smaller because we don't need the 2 pixel overlap there. Perfect. Okay. So those are our arrow keys. So now you can see what arrow keys I'm pressing, but right now if I press the arrow keys, nothing happens. So we need to render our separate color if the arrow key is down. And it's not just a separate color, it's a whole separate picture. So we've got this arrow key pressed picture that is stored in the arrow keylogger pressed variable. So what we can do is go to we need to go to our play state. We need to be here. Now we need to we can add some logic in our render function here. So we can say if love.keyboard.isDown, then we want to render the we need to give an argument to the isDown. So like let's do up first. So up, and then we get our up. We need the same X and Y positions, but instead of arrow key logger, we're drawing our arrow key logger pressed. So we can say if up is down, go ahead and draw that one. Otherwise, draw our normal key logger button. So now when we hold up, we get that little up animation on the keylogger. So that's cool, that's working. Now we need the same thing but for the other one. So let's do a little template here, love.keyboard.isDown, and we need left, and then we'll copy this, and we know we need it for right, and down. And then this will be the else of this one. So we can go ahead and say else, paste that bad boy. And then this one is the else of this one. So we can say else this bad boy. And then this one is the else of this. And then it's simple enough, like we just have to say the same thing. That's the real normal draw. Oh. And then we just need to tell it explicitly to draw the darker version if the keyboard is actually down. So we'll, all we have to do is, if it is down, we're drawing the keylogger pressed on all of these. And then we should be done with the keylogger. Okay, it's not quite working. Right is actually down, left is actually right, and down is left, so we messed that up. So this should be right, and then this should be down, and then this will be left. Okay, let's see. Yep. All right. We got the keylogger. So now you guys can see what I'm pressing. And we're only using 2 sprites for all of that. We could probably do it with just the 1 sprite, because we're drawing the same sprite, just rotating it. We could probably do that with 1 sprite and just change the color that we're drawing it at. And I'm tempted to just try it, just for the sake of only using 1 sprite for all of our keylogger. So I'm kind of curious if we can just, let's try it for just up. So like, let's pretend that we still just draw that original sprite, but the only difference is we love.graphics.setColor to be something darker. So let's not do complete black, but let's do like 30 all around. Let's try that. And actually, let's just do this because it's easier to type. Okay, this is why I set those constants. Okay, so see how that's setting the color for all of them? So we can actually get away with this. I think I want not so black, so I want it maybe a little bit brighter. And then just the other thing we have to do is set our white color for any time we're drawing the normal one. There's a way to highlight everything in our parentheses and delete it. And we can say white. So this we need for any of that. And we would need to set this dark color anytime before we draw the normal ones. It is more lines of code, but we can get away with only using 1 sprite. So now we're only using 1 sprite for all the keylogger stuff. Still looks a bit dark. So I'm wondering if we ease up on the opacity maybe. What if we say this is 200? Yeah. I don't know actually. Maybe maybe we do, let's see what 85 looks like all around. Okay, I like that. So let's give us this as a constant. So we'll go in here and we'll give it keylogger color or key, I don't know, faded. Let's get faded. And we'll give it a table that is all these values. And we will now render our keylogger at a color of, and watch me replace everything in the parentheses there by saying faded. So Change to faded. So, VI that. Oh no! Okay, we're cool. We're cool. VI that, and then change faded. Okay. Cool. Okay. So now we've got the keylogger working. And actually, it looks like the up arrow is lighter than the right arrow for some reason. You see that? Yeah. What's going on there? Did we not copy it over correctly? Faded? Faded? We're doing the same set color. So why would it be different? Does it look different on the stream here? Dude, I think mine's lagging hardcore. Because I'm looking at my stream and it looks laggy as heck. Let me just refresh this. I think it's my end that's laggy. I don't know. That looks really laggy. I guess I don't get why the faded color is dark there. We are setting it to white elsewhere. Maybe this is why we do it. We set this to white first. Why is it doing that? Yeah, I'm pretty sure I'm the one lagging here. Okay, so I'm just trying to figure out why my up arrow animation is lighter than the rest of ours. Because we're setting it to the same color. We're setting them all to this faded constant that we just added. Let's try changing this. See, why is that? Why is that just different? It's lighter. Let's go 105. It's like it shouldn't bug me as much as it does, but it really does bug me that they're not just all the same color. Like, why? We go into our play state. We're setting the color here for each one. It's always the same. We're setting it to faded, setting it to faded. Okay. Well, it's there. Now we can actually delete. We can delete our key pressed pixel here. We don't need this arrow keylogger pressed anymore because we're doing it with that set faded. Even though where did we? Oh. We're still okay. I see why it's wrong. Okay. All we gotta do is delete this. And then it'll be the same color. Because we were still drawing our old sprite there and then fading it, so that's why it looked different. Okay, perfect. Alright, we're back in business. Okay, so now you guys can see what I'm pressing. And now you can see why this is a problem. Because holding left and right does that. And holding up and down does that. Yeah, my stream is so far behind right now. Okay. Well, it's 8:55. I want to do... I think I want to do... I think I want to round those X and Y values. Now, Love 2D kind of handles the rendering for the X and Y at the pixels into the nearest integer pixel. So one thing I do want to do is, like, if I walk around and I go diagonal, we get these integer these decimal points of an X and Y position. So I think what I want to do is we can either truncate those so it's not calculating, well, I guess it doesn't really matter for the computer's sake. It's more calculation if we truncate it. So I think what we want to do is if no key is held down, we just want to flatten our... We want to truncate our X and Y positions. But the thing is, I don't want to do that every single frame, because if I'm just sitting here, I don't want to be truncating it 60 times a second. So I want to figure out a way to only do it once upon stopping movement. In the past on Joust, I had a was_released key function that I would use, say, like... But it's too hard because we've got 4 different directions, so we can't really... I don't know. I guess we can set a little toggle. So we can say if we're in movement, then we can go ahead, switch our boolean to true, and then if no keys are pressed, and if we're in movement, then we become no movement and we floor our values, and then we won't be resetting, we won't be flooring every time because we're not in movement. So I think that's the approach I'm going to take here, and we're going to go into our player, we're going to go up and init us with an in movement boolean, and we're going to say we start in movement false, and what we can do is anytime any key was pressed, we're going to become in movement. And then what we can do, so I guess the question is this as effective as just flooring it every single frame that we're not moving? I don't know. Yeah, I don't know. I feel like math.floor will be just as cumbersome as checking for input and assigning that value. So why don't we just go ahead and just do it? We'll just floor it anyway if we're not in movement. So what we can do is in our inputs here, we can have a if no keys are down, we're just going to truncate our X and Y positions. So if not love.keyboard.is down, and we need all of our directions here, and we can say we need all of our directions here, so we can say up. What do you mean by camera is clean? Left, right, and down. Okay. So we need, if not, keyboard is up, and not keyboard is left, and not keyboard down is right, and not keyboard is down, then we want to go ahead and truncate our X position and our Y position. So we can say, I just want to see, we would say our X position gets assigned our current X position, but floored. So what I'm trying to stop here is those crazy numbers when we're standing still. We should be floored to the next nearest integer. And we can't just floor this. We have to ask if we want to floor it. If we floor it, we'll just truncate it and always round down, but we want to round to the nearest pixel. So in order to do that, we want to we need to check our tenths of the place. So what we need to do is take our self.x and we need to multiply it by 10. Actually, how do we do this? Yeah, we need to see if our decimal point is greater than. So we can divide by, now what do we do? I feel like we almost figured this out. Yeah, I guess so. Everyone's streaming whatever's online right now. I don't even know what shows are online right now. Self.x gets, how do we get, okay, I got an idea. We divide by divide by 100. No. How do we just get the remainder? Do we, yeah, how do we just get the remainder? If we divide by the floor of it? Oh, no. I don't know how we determine this. Because we need to determine if we want to round up or round down. And to that we have to get whatever our trailing decimals are. But how do you get your trailing decimals from your original number? I'm not sure. Let's see what happens if we just floor it. I mean, it'll always round up. It doesn't look half bad. Oh, it looks not so great. It looks not so great sometimes, which is if it should have rounded down. So like all those decimal points, but as soon as I lift up, they're gone. So like we're getting reset to the nearest integer, but I don't want to always round up. I want to round down sometimes. So it's like, how do we ask to the nearest integer? Round to nearest integer. So okay. This is a smart way to do it. So you're always going to round down, but you're going to add 0.5 before you round down. But does that mean it would go... Yeah, that means it would round up if it should round up. Even though it's rounding down to the next number because we added 0.5. That's a good idea. Yeah, that's a really good idea. So we'll just math floor it and add half a pixel, and then that'll handle our rounding. That's a great idea. Because, like, let's do the math here. So, like, let's say we're at 200.4. We would add the 0.5, which gives us 205.4, and then we'd floor it, which gives us 205, which is the next number. But if we're at 200 wait a second. 200.4 should round down. Yeah. And then we add 0.5, that gets us 0.9, but we're flooring that 200. Yeah. That's a really smart way to do it. Okay. So we don't end up in the exact position by the time we let go, but we get rounded to the next nearest X position. Now, why don't we just... Yeah, we can't... I don't like that there's so many decimals when we're moving diagonally like that. So let's just handle that and then we'll call it a night. So let's go to our multiple input handling. And we've got... we don't need any of this. See, look what I was doing. I would divide by 100, and then see that only works if it's a multiple of 3, so that's really not good. And then what we'll do at some point too is add in notes so that we can hop to specific sections of the code, because we're gonna be, you know, we're already at 288 lines of code for our character class. So instead of scrolling up through 200 lines of code, we can just find the spots that we're doing our magic. If we leave good comments, we can kind of jump to them if we know what it's called. So let's see our multiple input handling, which is what I'm looking for right now. So we can go ahead and add this multiple input handling, and now if we're at the bottom of the file, we can say, where's our multiple input handling? And we just say multiple input handling. Okay, cool. So there's that. Here, this is where we want to do our math.floor, and actually we want to floor it to the nearest 10th place. So what we want to do is multiply it by 10, and then we want to divide by 10 after we're done flooring it. Is that right? Math.floor, and we will multiply it by 10 in parentheses, and then I think we actually want to divide by 10 before we floor it. Multiply it by 10, divide by 10, then floor. Okay, so now we should have 10th place, 120, 120. We should have 10th place accuracy. Math.floor, we got that, we got that. I guess we don't need this. Okay, so for up and right, we've got that 10th point accuracy. We just need our other directions. So, and actually, you know what? Since we do the same logic, we can just add this into a function, right? So we can just say that this is going to be our round, or let's say that this function is called Normalize Vector. So Normalize Vector, and it's an argument that it's a function that doesn't take any arguments, but what it does do, and actually it just modifies ourselves. I think that's okay. So we don't need to parameterize this or anything. So we can just take this Normalize Vector function, and anytime we do this, we just do our function instead. So we just do, we're doing it right here. We're gonna just normalize our vector. Why? There. Okay. So delete this, normalize our vector, and then I actually messed up there. Because the way NeoVim works, every time you delete your you lose whatever you had saved up in your copy and paste buffer, so I just have to retype it, but it's okay. Normalize vector function, and then normalize vector. Okay. Oh, okay, well, maybe we do have to parameterize it because it doesn't have access to self. So what we'll do is we'll just say, can we give it self like that? It's because the values it's manipulating are local to the function, so we need to just tell the function what self is so that it can run it. So I guess we did need to parameterize it. And then here we'll say that this requires a self. See, and I think this is actually different. I think we need to say, we can't give our parameter the same name as the variable because I think it doesn't like that. So we're gonna put in, oops, character, and then character. Let's see. Okay, so we've got 10th point conversion there to the nearest 10th. Gosh, I feel like it makes our judder worse, but I really don't. I just looked over at the stream and I'm like, it's frozen. Okay, we'll keep this for now. Let's have both walk over our keylogger. And then we'll call it a night. It's already 9:12, so let's just have both walk over our keylogger. So we're doing our keylogger. We need to render Kvoth after all this. So we'll just come down here. Okay. Oh my god! Nice. So he's over the keylogger. What's happening here is that now that we're doing all of our rendering here, we're doing our set font size elsewhere. Where is our font size? It is tiny font. Tiny font is what we need. So if we go into player, go down here, we need to set our font to tiny font down here. Love.graphics.set font gets tiny font, and then hopefully back. Cool. Okay, so we've got the keylogger in action. We're able to see what keys I'm pressing. We're able to see Kvoth even though I'm pressing stuff. We rounded all of our X positions to the nearest 10th place. Now, actually, I'm thinking that really is a bad idea, because it just makes it less accurate. I'm going to keep it for now, and I'll test it on my other machine and see if it looks bad. But the other thing is we're doing more computation than we necessarily need just to make it look nice on the debug screen. So I wonder if there's a way to truncate it on the print in the print function rather than the actual value, but I don't exactly know. So I can look into that for next stream. Let's give us a note to check that. We'll say, and you know what, I did this, but this didn't work. So I'll put a question mark here. I want to say that we want to check rounded, or check if print function can round decimals. And if it can, then we'll get rid of that. If so, stop truncating X and Y positions. And then the other thing we want to do, make strafe walk more accurate to Link's Awakening. And this depends on the functionality of our game. So in Link's Awakening, when you know how we've got it so that the most recent direction you push is the direction you're facing, which makes sense to me. But in Link's Awakening, if you're walking one direction, then you hold another one, he doesn't turn, he just strafes. And I think that's because it's a game that you have a shield that you hold in front of you and a sword, and I think it's really quite necessary for the gameplay to do it like that. So the thing is, I don't exactly know. I'm not really going to have a sword as Kavoth. I don't know exactly what we're going to be having as weapons and stuff. So I don't exactly know if we should implement that. So that's why I put a question mark on our notes for make strafe walk accurate to Link's Awakening. It depends on Kavoth's moveset and the playstyle and how we want to do that. The other thing I want to do is I want to change velocity to be Link accurate, because we're a little bit faster than Link's Awakening. I timed it last night. We're about 0.4 seconds too fast walking compared to Link's Awakening. And then the other thing is we need to increase the buffer, increase character walking borders. How do we want to say that? Increase character walking borders, and we'll say to be Link accurate, because you can kind of right now, like Kavoth kind of bumps up against the wall as soon as his square touches it, and his pixels aren't flush with the left side. So see, when he's down, his hair is perfectly flush against the left side, but when he's facing left, he's got 1 pixel of room there. In Link's Awakening, you can actually go like up to his nose, you can walk through, and then once you go past that point, that's when it initiates the change and the swoop onto screen for that next page. And same with the bottom. It's like we're cropping out right flush at the bottom, but in Link's Awakening, you can go a little bit further before you initiate that page turn, or whatever you want to call it, transition, screen transition. So we want to get that accurate as well. And then once that's accurate, and we're happy with that, we can start drawing our backgrounds, start adding some pixel art for our buildings, start mapping out what our game location's looking like, and all that good stuff. So we'll call it a night. It's already 9:19. We'll call it a night. Let's check our git diff. We'll see git diff, and actually we need to remove the picture that we're not going to be using so we don't accidentally commit that, because we don't need it. So we're going to go to source pics. We don't need our key pressed because we're doing it all with one picture. And then we added a normalize vector function, took out some nasty code. We use our normalize vector function, cleans it up a bit. We rounded our X and Y if we're not giving any input. I still want to see if there's a better way to do that. I don't know if I like flooring it every frame that nothing's happening. I don't know if I like that that's happening. Probably don't. And then we are doing our keylogger. So that was pretty good. So let's go ahead and git add, and we'll say added keylogger and normalize vector function, and then rounded x and y if standing still. Okay, and we'll get push it, and then that's it for today. I'll be streaming tomorrow too. I'm trying to stream every day, so we'll see how that goes. Thanks for watching, and I'll catch you on the next one.